No, because some are going to have the same numbers. Okay, revolving around the y-axis. No, because if you want to find the work, it is online. Okay, girls, so I'm going to draw my axes, and then I have y equals 2, and I have the square root of x. Let's see. So the square root of x looks like this. And I am going to bound it by 2, the y-axis, and the square root of x. So 2, no calculator, the y-axis, and this. So it's that region right there. Okay. So I'm going to reflect that around the y-axis. There it goes. And so it's going to be over here, and it's kind of small. Yeah. So it's just a disk, right? So it's pi r squared times the thickness. Courtney, what's the thickness? Delta x or delta y? Delta y. Because the disk is going to go this way. Think of money. If it goes this way, it's x. Just look, you want the thickness right here. What is that a change in? It's the change in the y values. Okay. Jack, put your phone away, please. Now, how do you find the radius? The radius is this length right here, which is what coordinate on this? This is all geometry. It's x comma y. Is it the... Oh, yeah. Thank you. What's the radius here?
Wait, no, you can't. Quizzes are...
I know. What's the radius? X or y? X. So this is going to be x. So you're going to have pi x squared delta y, and when you add them all up, I'll put the pi outside, and it's x squared dy. What variable do I want now? I want the y. So what is x? Y equals the square root of x. So I have to solve for x in terms of y. So we'll square both sides. So y squared is equal to x, and so we're going to put that in there. So it's pi. Then they did ask us to integrate this. And so it's the integral of y squared squared. You see y squared again? Because it's x is squared and x is y squared. dy, and where are we going to go? Starting at 0 and go up to 2. And this is in the non-calculator section because it's not that hard to do. So it's 0 to 2, and this is y to the 4th dy. What's the antiderivative of y to the 4th? 5th over 5 from 0 to 2. Nice. 0 gives me 0. So it's pi 2 to the 5th over 5, and you should know what 2 to the 5th is. 32, which is answer A. And then I check over here on the board, and there it is. It's A. You got to help me out with where the question is. For which, 8? This is the first page. This goes in order. That's why I scanned it. 6. Yeah. Oh, I've just copied it. It's okay, so it's C. Find it on it. Okay, other questions from the multiple choice packet, Jack? Hmm? I think there's maybe some issues with 21 and 87 on the first side. Okay, 21 is the request on page 1.
Vertical, horizontal.
Okay, 21 is a hard question, so I was really kind of expecting to have some questions on this one because, well, we're going to talk about that. This is the position graph, right? And it says, where is the velocity? Not is it speeding up. Where is the velocity increasing? How do you know if a function's increasing? Its derivative is positive. So v prime has to be greater than 0. What is the derivative of the velocity? It's the acceleration. This is the position here. So the acceleration is what derivative of the position? V is equal to dx dt. So what's a equal to? Pardon? dv dt, which is the second derivative of the position. So that's one reason why it's hard, and you're given the position. They're asking where is the velocity increasing, not is the particle speeding up or slowing down. This is a velocity question. Okay, how do you know if the acceleration is positive? How? How do you know if the acceleration is positive? If this is the second derivative, that's what we want, the second derivative of the position to be positive. What does that tell you about concavity? It's concave up. Okay, Courtney? So where is this function concave up? It's concave up from here till I hit, no, it says the inflection point is t equals 2. It says 6, let's see. Okay, Evan? Nope, it's not concave up. You have to look at the second derivative. Okay, Jack, put your phone away. Because this is the position graph. Let's say this again. It's with multiple choice without the multiple choice answers. Okay, the position, this is the position curve. I want where the velocity is increasing. The velocity is increasing when its derivative is positive. Okay, girls, what's the derivative of the velocity? It's the acceleration. If I were given the velocity curve, I'd be doing this differently, but I'm not. I'm given the position, and the acceleration is the second derivative. So if the second derivative is positive, then my picture here has to be concave up, and it's only concave up in this region. It's a hard question. So the answer is A, between 0 and 2. Pardon? I'm waiting. Is that okay or not yet? What about 87? Not the solutions are online if you find a solution key to 2008 multiple choice. No. Not unless we switch it. As far as I know, it's not. Yeah, you have to go in order. Carter. We may switch it just because some people might be gone on Wednesday. It's not multiple choice answers. They're free, so you can't just pass answers around. And you can't just memorize answers. Yes, you have to show the work. Okay, what about number 87? Did you get 80? Did you do 87? Hello, we're doing math. Math. Jack, where's your packet? I suppose. Or 83. Did you guys try those? How about 87? Do you know how to do 87? Thank you. Somebody finally said no. Okay, 87. Can you guys push your chairs back a little bit? It's like I have no room, not forward. Okay, an object is traveling on a straight line. It has a position, and this is a trick you have to know. This is 100% guarantee this trick's on the exam. 100% guarantee. It is. The velocity is given by this, and this may be an issue of how do you put it in your calculator too. And you can tell by the numbers that there has to be a calculator problem. They're never going to make you do 3 decimal places like that. What is the position of the object? I want the position at t equals 3. How do you find your position? What do you do with the velocity? You integrate v of t dt from t1 to t2 by the fundamental theorem of calculus, is the antiderivative of the velocity. So you want to use s or x, it doesn't really matter. So it's s of t2 minus s of t1. And they gave us one of the points. They gave us x of 0 or the s of 0, it doesn't matter, equals 2. When they give you one of the ordered pairs and they say, find out where it will be later, then I know I'm going to use the fundamental theorem of calculus. And you'll see it in the free response, and you'll see it in the multiple choice, as can be seen here. So I'm going to integrate from 0, and I want to go to 3 seconds and see where I am. Of v of t, well, let's put v of t in there. So it's 1 plus t squared to the 1/3 power dt, and you have to use the caret in the 1/3, is equal to s of 3 minus s of 0. And I want to find s of 3. So what is s of 3? It's equal to s of 0, my starting value, plus the area under the curve. It's always going to be that, actually. So if you can remember just to add in the starting value, you can. Pardon? No, it's s of 3 minus s of 0. Solve for s of 3. I add s of 0 to both sides. If s of 0 turned out to be negative, which it could be, if you're talking about a particle on a line, yeah, it could be. So what is s of 0? It's 2. So it's 2 plus, and then you integrate with your calculator. You can't even do this one by hand because it gave me that my starting value was 2. And so you need to find more of these problems. That's why I picked it out, because you need practice with that so that when you hit on it in the exam, and you will, that you get it, because you will get it. I don't believe it's a calculator tomorrow. I think my favorite calculator. Actually, you'll find the non-calculator using the calculator. Yes, tomorrow's the individual. And then after break, Monday, Tuesday, Wednesday, we're going to simulate going through the 2008 exam. So we're going to actually do that in class. And we'll do most of the 2008. We won't get it all done. We'll get most of it done. And then we can get some grades for you. So you have some idea where you're starting. Not a grade for the class. A score for you. Yeah, I think we'll put this in quarter 4. Yes. Because we don't have any other tests. It doesn't matter because remember it's cumulative. So it's the 3rd quarter added into the 4th quarter. It makes no difference. Yeah. Okay. Now, do you have any problems doing the calculator on this one, you guys? You have to use a calculator. If you listen to me, I said this can't be done by hand.
So then question, does that mean tomorrow choice and no calculator, we're not going to give us problems like this?
That would be correct.
So we'll have easy problems.
Yes, easier. And you can see 83 is a calculator.
So quarter 4, after quarter 4,
No, we'll only do it once in the semester because that's all we got. Okay, how about some other ones on here? Sure, we can do work. And then I got to get back these yellow quizzes, but I'm waiting for them to come in. Pardon? Or we could do an FRQ.
oh yeah, the yellow quizzes.
Tomorrow, I don't think so. I know. But I have 3 people who are still taking it. So let me pause this somehow.